Hello everyone, today we are learning the subject of electromagnetic field theory or electromagnetics. So here we will learn the chapter on your uniform plane view. So introductory part, what is the use of here your uniform plane, how many what we can say the electric as well as the magnetic fields are used and which equations are useful. If my wave is propagating, my wave is traveling in the space, what will be the effect of your the equations by using the various scientists they have made the many equations such as like your the Maxwell equations plays a very vital role in the electromagnetic field, in the transmission line, in the uniform plane wave, in many more. Okay, so here what is the role of your the uniform plane wave? If wave is propagating uniformly in the space, what will be the effect, how the equation can be utilized, how we can find the parameters which are related to the uniform plane wave. That is important. That's why we are learning this subject. So here will be the two fields, the electric as well as the magnetic field, and that will be traveled uniformly in the space. Similarly, we are interested to find out the speed of the electromagnetic waves. Okay, we need to study about the electricity, we need to study about the magnetism, and we need to apply the experimental things to find out the parameters, just like the permittivity and the permeability in the electric as well as the magnetic fields, which are the constant in the vacuum. So if we are going to find out the speed of the light, so at the time the c will be denoted as the speed of the light. C is equals to 1 by you can say epsilon and the mu. So if you want to substitute the value of the constants, that is nothing but the epsilon 0 and the mu 0, that is the permittivity as well as the permeability of the vacuum. If you substitute this constant value, definitely you will get the speed of the light, that is a 3 into 10 raised to power 8, which is measured in the meter per second. So in this way we can calculate the things, okay, and we can even find the equations which are related to the Maxwell's. So here these equations plays very important role in the entire electromagnetic fields while we are learning the subject. So Maxwell's equations, so these are the few formulas which are in terms of the differential form, in terms of the integral form, so which are related to the free charges or in the free space. If we are thinking about the charges, if we are thinking about the current at the time in the form of the differential as well as the integral form, we need to think. So here the various scientists, they place the what we can say the derived expressions to find out the parameters, just like the Gauss's law, just like the Gauss's law in the magnetism, Maxwell's equations, and the Ampere circuitry law. So here in terms of the gradients, in terms of the divergence theorems, all these things in the electric as well as the magnetic field we have calculated with the help of using these scientist equations, Maxwell's, Gauss's, Ampere's, all these things we can find easily. Similar to that only, so just like in terms of the dot product, in terms of the cross product also, we will be able to find the electric field intensity, we will be able to find the magnetic field intensity, electric field density, and the magnetic field density. That all the parameters we can find with the help of these laws, with the help of these equations, in terms of the differential form as well as in terms of the integral form. So here also, what is the use of this integral of closed surface of E dot dl, what is the use of integral of closed surface of B dot dl, E dot dA and B dot dA, that is mentioned here clearly. This equation, or you can say this law, is used for the line integral of the electric field along the boundary condition is useful. Whenever you are having any closed curve or the path, that time this is applicable. Similarly, this is also the line integral of a magnetic field. Whenever you are having, if you want to find out any closed boundary, at that time you can use this law. Similarly, the electric flux intensity, electric field intensity, as well as you can find the psi and the phi, that time also you can use if you want in the boundary condition related to the volume. Similarly here also the magnetic flux what you can say the densities, that also you can find if you want to measure in terms of the volume by considering that things. So that just like the differential line, the differential surface area, and the differential volume, likewise you can find. So all the Maxwell's equations which are related to the Gauss's law for the electric field, Gauss's law for the magnetic field, the Faraday's law of electromagnetic induction, and the Ampere's circuitry law, all these things are applicable. All these equations and the laws are applicable for finding the various parameters, like in terms of the lambda, in terms of the what you can say the wavelength, in terms of you can say the the electric field, magnetic field, electric flux density, magnetic flux density, even you can find easily the characteristics, impedances, many parameters you can find with the help of this equation. So here also, if you are concentrating the electric as well as the magnetic field, and if you want to write the equation in the electric as well as the magnetic form, and you need to focus on which particular axis my electric field is there, my magnetic field is there, how my wave is propagating, traveling from a particular point to the entire end, so from the source to the destination. So likewise you can write the standard equation by considering, you can set the few constant, you can by considering the angular frequency, by considering with respect to the time period, all this thing you can write. Here will be the reference point, here will be the electric field, and this one is nothing but here the magnetic field, and these are nothing but the amplitudes. At the peak value you can find your electric and magnetic field, and even you can concentrate on your the angular waves, how many number of angular waves are there with respect to the time period, that you can Similarly here, if you are interested to find out the energy density, okay, in terms of the what we can say, the electric field as well as the magnetic field in the free space, at that time also we need to find out the equation, how we are writing that equation, how we are calculating electric and magnetic field, and likewise in the transmission of energy, because we are interested in the energy, we are interested in the powers. So at the time we can write the equation, we can represent that equation which are related. So here will be the electric as well as the magnetic field, and the associated, that is nothing but the energy density is denoted by this U. So in this way the work done and in the form of the electric and the magnetic field, and you can find easily the energy density which is associated not only in the electric field but also the magnetic field in the free space. So likewise you can equate these two equations, you will be able to find the total entire energy density, that is nothing but the U in terms of electric and magnetic, and you can conclude both are equal in the free space. Okay. So few equation you can exercise or the few examples which are related to the uniform plane wave by concentrating the parameters of the equation, just like the here the E equation is mentioned, that is the amplitude on the peak value along with the sine wave, and here will be your the constant parameters, the omegas, the betas, with respect to the time period, and other thing is mentioned, and which axis, on which particular axis my electric fields are placed is mentioned here. If my Ex is there, then definitely Ey and Ez will be the 0, other plane will be the 0, and we can find, if we are having such type of equation, we can find the speed, we can find the frequency, we can find the wavelength, the time period, the initial phases, and the electric field amplitude and the polarization, as well as the magnetic field. All these things we can find easily if we are having such type of equation. So the standard how we can start, that is with in which particular axis my electric field is there, okay, how you can placing with respect to the time period, and this one is the standard equation. If my electric field is at the x-axis, so at this will be amplitude, this will be the constant term, and with respect to the time period, likewise you can substitute the value, you can find easily the constant term, the velocity of light, the wavelength, the frequency, and the other factors. So this is also one of the what we can say other exercise which is related, other parameters also you can find in the magnetic field in the same the numerical is there, same exercise is there, definitely you can find the time period also if you are having the frequency. So in this way you can find many parameters. So here also how you can find the energy transport, and how you can find the power losses, how you can find the what we can say the electric as well as the magnetic field in the cross product in terms of the what we can say the power that is possible with the help of the pointing vectors. So this pointing vectors P is equals to E cross H, that pointing vectors can be denoted by S. So that is also possible, okay, while you are going to learn the study, okay, this electromagnetic field or uniform electromagnetic waves, how my wave will be propagating uniformly, and how that EM wave can be transferred from the one location to the other location. What will be the losses, what are the power losses, how average power you can obtain, that is possible with the help of this pointing vectors and the pointing theorems, that is mentioned clearly here. What is the role of your the electric and magnetic field by using these theorems, and how you can calculate the average power as well as the power losses, and all these things is possible. In this way, even you can further study about the this Poynting vectors. You can substitute the value of your the electric as well as the magnetic field by concentrating the or by mentioning the speed of the light, and you can find the current, how much amount of a current is there, how much amount of intensity is also there, how much time is required for getting all these things, that you can calculate easily what will be the your the what can say the peak voltages and other the VRMS and the VM values, you can find easily all these things. So in this way, this is one of the example, or you can say one of the exercise. If you are having the wavelength is mentioned in terms of the meters, the power is mentioned in terms of the watt, and you can find the RMS value, you can find the peak values in terms of the electric and magnetic field. So here will be how you can find the intensity is also mentioned there, with respect to the power and the electric field intensity. So likewise you can find easily, you can substitute the value with respect to this formulas, and you can find the unknown powers. So here also all these things we have placed. This is also how we can find the polarization of what will be the effect of polarization in the electromagnetic wave is mentioned here, how the transfers is happen in the electromagnetic waves, what is mean by the polarized wave, that is mentioned in the electric field as well as the magnetic field, what is the direction of electric field vectors, you can say, if the direction of the polarization is there, what will be the effect, how the what we can say the wave of electric and magnetic will be propagating in the positive z direction or other direction, any other, how they are polarized, in how my equation can be right, the standard equation can be right in terms of the electric and magnetic, how my the speed of the light can be mentioned, how I can get my the Poynting vectors and all, that is also possible. So transfers of your electromagnetic wave is nothing but the polarization. So here the example how we can simplify. If you are having the standard equation of the electric field, you can substitute the parameter of frequency, the time period, the angular velocity, the angles, beta, everything, and you can find on which particular axis is my wave, and likewise with this x, y, z, and in which from the which particular point my the wave is traveling. Accordingly, what things will be the zero according to the rest of the parameters. So likewise we have I have explained here the basic or introductory part related to your the uniform plane wave or the subject of your the electromagnetic. Thank you.